Good morning everyone. In the last video we have discussed about the meat system and the surrounding and type of the systems. Today we are going to discuss about the state of matter. When we talk about the state of matter, we talk about the physical state of matter, and there are three physical state of matter, that is solid, liquid and gas. But within the physical state there are several state of matter are also available. That means the liquid at 0 degree Celsius must have the different state, and the same liquid at the 100 degree Celsius must have the different state. If at both the temperature the system is surviving as a liquid. So the system have the different state at different temperature, different pressure and different volume. So whatever the state of matter is there, that is determined by the state functions. And the pressure, volume and temperature are the major state functions. These are the state functions are the path independent functions. So the pressure, volume and temperature are the factors which determines that what will be the state of the matter, even within the physical state. With the varying temperature, with the different temperature, the state of matter must be different. So you can say that the state of matter is determined by the state of function, that is the pressure, volume and temperature, and these of the three are the major state functions. But when you will talk about the other state functions, because only these three are not capable to explain all the functions, all the state of the system, so whatever the other state functions, then we can talk about the internal energy. What is the internal energy? The overall energy of the molecule within a system is called the internal energy. That is the sum of the kinetic energy as well as the potential energy. You can call it mechanical energy, you can also call, but this is the sum of the kinetic and potential energy for the molecule of any system is called the internal energy. What is the internal energy? Internal energy is designated by the U, that is also a state function, and we can say that the internal energy change is bring by the work done on the system. We can do any of the work through the system to change their internal energy. We can change the internal energy by providing the pressure, by moving the piston, that is the work. We can change the internal energy by providing the heat. So whatever the heat and work is provided to the system, that can also be considered as the internal energy change. So internal energy change is also a state function, and here internal energy change is sum of the heat and the work. So in this way you can say that the delta U, that is the internal energy change, equal to Q plus W. This equation is also a mathematical representation of the first law of thermodynamics. That means the energy of the universe remains constant, that neither can be increased nor can be decreased, because this universe is a isolated system. The energy is not coming from outside and neither it is moving to outside. That means the exchange of energy in this universe is not taking place. So you can say that the overall energy of the universe must remain same. Energy neither can be created nor can be destroyed. Only the energy will change from one form to another form. The heat will change in the form of work, work can change in the form of internal energy, and like that. That means the energy of the universe remains constant. Now we are going to see these are the factors, that is the heat and the work, and we are starting from work. So here we are talking about the work. What is work? We say that the work W equal to force into displacement cos theta. As a parallel force is working for any system, then the value of cos theta will be 1. So you can write that work equal to force into displacement F into D. In this condition, in this cylinder, if we are considering that this is the piston, which is working with the F force, a force F is applied on the piston, and because of the force this piston moves here, and this movement is displacement is D. So the force F is applied on the system and the displacement D takes place. So the work W equal to F into D. This is the equation of the work, as you know already. Here if you will see that what is the pressure, then pressure P equal to force applied per unit area, force upon area. Here we have taken that the area of this bisection is A. Then pressure equal to force upon area. Then what's about the force? Force equal to pressure into area. Similarly, you can say that the volume delta V equal to, if the volume of this area, that is the area of the displaced air, you can say, then if the volume of this area is delta V, then the volume equal to area by section A into D, that is the area of base into height, that is the volume. So here the height is the D and the area by section is A. So you can write A into D, or D equal to delta V by A. From these of the two relations, we can find that the force, W F D, W equal to F into D. तो F की वैल्यू यहाँ पे हमने रख दिया PA, और बचा क्या आपका D की वैल्यू, वो हो गया डेल्टा V बाई A. Now from this equation W equal to A is cancelled by A, so it will be P delta V. This is called the work. ये तो उस कंडीशन के लिए है जब वॉल्यूम वेरिएशन हो रहा है. अगर वॉल्यूम वेरिएशन नहीं हो रहा है तो क्या होगा? देन देयर विल बी अ टेम्परेचर वेरिएशन. वर्क टेम्परेचर वेरिएशन से हो सकता है या किसी और से. सो अकॉर्डिंग टू PV इक्वल टू nRT, you can write that the work equal to P delta V equal to delta nRT, or W equal to nR delta T. So these are the different formulas of the work. Work itself have a two clear categories. The first work is called the reversible work, and second work is called the non-reversible work. Sometimes work is reversible and sometimes work is non-reversible. You know well, if the process is proceeding in the smaller steps, the process will be reversible, and if the process is proceeding in the bigger steps, the process will be non-reversible. जब भी छोटे छोटे स्टेप्स में कोई भी प्रोसेस चलता है वो रिवर्सिबल प्रोसेस होता है, लेकिन अगर वही प्रोसेस बड़े स्टेप्स में चलने लगे वो श्योरली नॉन रिवर्सिबल प्रोसेस की कैटेगरी में आता है. उसे रिवर्ट करना थोड़ा मुश्किल हो जाता है. अगर हम एक सिंपल सा एग्जांपल, डेली लाइफ एग्जांपल दें, तो सीढ़ियों से चढ़ के आना ऊपर और सीढ़ियों से चढ़ के उतर के नीचे जाना, दोनों ही चीजें आसान है. लेकिन अगर छत पर से नीचे जाना चाहे सीधा कूद के जाना, जाने के बाद क्या हालत होगा वो अलग बात है, लेकिन कूद के जाना बिल्कुल आसान सा काम है. कूदेंगे नीचे ही पहुंचेंगे, लेकिन नीचे से क्या कूद के ऊपर आ जाएंगे? इतनी जंप करने की कैपेसिटी है? श्योरली नहीं है. ऐसा नहीं है कि हम उतना वर्क नहीं कर सकते, हम छोटे छोटे स्टेप्स में उतना वर्क कर सकते हैं. सो ऑलवेज दैट वर्क which proceeds in the smallest step, that is called the reversible, and which is not proceeding in the such step, that is called the non-reversible process. So it's enough for today. In the next video we will discuss about the next topic. Thank you and have a nice day.